I'm going to be talking to you guys about renewable natural gas as a carbon offset. Hey, thanks. Is it the right one?
Yes. This is for it.
Cool. So just to clarify, my new-ish title, my newest title is VP of Marketing and Business Development. So business development includes renewable gas initiatives, gas technologies that are above and beyond just the standard cooking, drying, and hot water, such as cogeneration, boilers, things like that, larger technology. So that's how I spend my days, but today we're going to talk about some carbon offsets. First, I want to give you a little background about Hawaii Gas. So we're a 100-year-old company, actually a small company. We've got around 325 employees. About a third of those employees are non-union. So 2/3 are the guys that are actually out putting our pipes in the ground, and they're union employees. So about 100 people that run things like legal and marketing and human resources, the non-union side of it. So going back to this, you can see that's why I have marketing and business development, because we all wear a lot of hats at Hawaii Gas. We're not a huge company, but we do a lot of great things. We are the largest propane supply company in Hawaii. We have propane storage on all islands. Why that is critical is because here on Oahu, we make synthetic natural gas. And we distribute it through our pipeline. So pretty much from Campbell Industrial all the way through the energy corridor, through Waikiki and to Hawaii Kai, that's our pipeline gas. And that's synthetic natural gas that's manufactured here in the state. The way we actually manufacture natural gas is there's a byproduct of the refinery process called naphtha. It's kind of the lightest piece of the barrel of oil. So oil's brought into Hawaii. The refineries make gasoline and jet fuel, which is how we fuel our cars and tourism. The top part of that barrel is naphtha, and we refine that using our synthetic natural gas refinery, turn it into methane, and it's natural gas that you see. The tiki torches that are in Waikiki, all of the chefs cook with gas. That's actually made here, right here on the island. So we actually, in our pipeline gas, we actually have 4 different types of fuel. That's our pipeline map right there. If you don't recognize it, that's the south shore of Oahu. So our SNG, I just kind of described that. That's made from naphtha. We also have propane on all the neighbor islands, as I described, because we have no synthetic natural gas pipeline infrastructure. So if someone at a hotel, let's say on Maui, wants to cook with gas, they use propane. So we can inject propane in air to match the BTUs of synthetic natural gas. We do that occasionally. We also have PUC authority to import up to 30% of liquefied natural gas, which this is all methane that we're talking about here, except for the propane. We so far have not imported very much LNG. I think we've brought in a couple ISOs because it's a little more technical. It's different than our SNG process. But the latest, and what I'm here to talk about today, is the renewable natural gas Honouliuli wastewater treatment plant. Renewable natural gas manufacturing has just come online as of December of last year. It's my favorite project. So what is renewable natural gas? It's essentially pipeline quality biomethane. So it's the gases that come off of wastewater, and it also can come off of landfills through the normal degeneration of organic material. So that is biogas. We capture that biogas and essentially we clean it. And I'll go through that process in a couple more slides. But we clean that to make it pipeline quality, so it's good to cook with and power things like hot water heaters, dryers, things like that. So RNG comes from 3 sources here in Hawaii. We can get it from wastewater treatment plants, we can get it out of landfills, or we can grow crops and run them through anaerobic digestion. to make that biogas that we then clean into biomethane. So wastewater treatment plants, you can kind of see that picture there. That is actually our Honouliuli wastewater treatment plant, and that little green container there is the piece that is cleaning that biogas and injecting it into our pipeline. But I'll have some better pictures later. But that is really the, it's not anything sexy. It's not anything anybody wants to really have fun talking about. It's wastewater, comes from sewage, but the gas that comes off that has been flared for many, many years. I think it's almost 40 years that plant's been there. And all that biogas has just been flared. So now we are able to clean it, capture it, and utilize it. One of the challenges with landfill gas is it's a little more expensive. First of all, landfill gas is a lot more finite. Wastewater just keeps coming. Landfill gas is really about what's buried already in the landfill. And so there's a finite piece to it. There's also a lot of contaminants in landfill gas. But it is available here in Hawaii on Oahu, Waimanalo Gulch, which is on kind of over by Ko'olina. I think it's by PVT Land. In fact, it's right over in your neighborhood, Steve. But they have the highest percentage of waste of gas in landfills. And then ag crops is the only scalable piece that we have for RNG. So you can grow crops and run them through anaerobic digestion, and then we can capture, clean, and inject that as well. So this is a little model I put together on how RNG is actually made. So this is probably right out of an 8th grade chemistry class. Essentially you take any kind of waste that's organic, you run it through anaerobic digestion. Landfill is a little bit different. You actually capture that methane, you have to clean it, and then you can inject it as pipeline gas. So I'm going to take you guys on a tour now of the Honouliuli wastewater treatment plant through pictures. Just imagine the raw smell of sewage, and then it will be like you're there. This is actually the better tour. When you're actually there, it's tough. It's tough. So this is the view from the ground versus that view from the air. Those tanks in the back, they have some wastewater in them. It's not pretty. So this is the water removal system. So the key to turning this biogas into biomethane that's usable is you got to get the junk out and you got to dry it. So the first thing is the water removal. Next is activated carbon. We send it through this filtration system, and that takes out most of the contaminants. Compressor, we actually have to compress the gas because the next piece of filtration is then two-stage membrane. So you have the gas at high pressure, and it's essentially like pressing the gas through a screen. So you press it through high pressure through a really like microscopic screen, and it takes out the remainder of contaminants. Then gas analyzer, that's the high-tech mechanical infrastructure that actually tells you that the gas is pipeline quality methane. Then the human-machine interface, the HMI. This is a big touch screen that's in the control room that gives you a kind of a flow chart style that tells you exactly what's going on. If you have low vacuum pressure or if you have a high CO2 level, that's where this ends up. So talking a little bit more about renewable natural gas as carbon offset, you essentially have three types of I guess, in the carbon cycle here. You've got carbon positive, which that's digging out already sequestered carbon. You take the old plants and animals that die and they turn into oil in the ground, and that's there safely and it's not in our atmosphere. When you mine that out, it now becomes carbon that enters into our atmosphere. So if something's carbon neutral, you can see like you got the little windmill and solar there. That's not touching the carbon chains. So it's essentially making energy, you're providing energy, water, wind, and solar, without reintroducing new carbon into the cycle. So it's a carbon neutral energy source. You also have carbon negative energy, which there's energy crops and biomass can oftentimes be carbon negative. And what that means is you're actually taking carbon out of the carbon chain and putting it back into a sequestered element. So you can actually have carbon neutral solution. A real easy way I like to think about this is when you're growing energy crops, those crops themselves are removing carbon from the atmosphere. Then you're running it through anaerobic digestion, making energy out of it. And it would be a carbon neutral solution if it wasn't for the negative piece that's actually pulling carbon from the atmosphere. So here is how we actually upgrade our gas. And this is our data here. We've got 4,280 metric tons of CO2 that are eliminated annually. And the way that's eliminated is the biogas. Before we built this, there was the biogas that was being burned at the wastewater treatment plant through a flare. And then we also had our synthetic natural gas that were being burned by customers. So we're eliminating the S&G being burned by utilizing the biogas for energy. So I think this might be my last slide. The actual production. So we've had February and March, or we've had some kinks that we've been working out. So we're actually expecting 800,000 therms annually. So these are a little bit low. So if you look at the bottom, our total cost to build this was about $3.2 million. We do have some electrical use that it does require, but we are looking into other ways that we can utilize the biogas or other renewables for that electricity. And then there's a little bit of an operating cost there. So this is our data. So one of the key components to a renewable natural gas generating facility is making sure that it pencils out. You have to have enough gas production that we can sell the gas to offset some of the higher startup costs. And here's some good aerial pictures. If you guys ever want a tour of the wastewater treatment plant / RNG facility, feel free to contact me. And we do occasionally do tours, and they're not as horrible as I've made it sound. But thank you for your time.